Alright, so this video is part of a compilation of videos I've done on Epsilon-Delta proofs, and if you want to see the full compilation, there's a link down in the pinned comments below. But I hope you love this standalone video just to digest this one proof, and I'm excited to bring it to you right now. Alright, so the next Epsilon-Delta proof we're going to do is this limit, which is now a quadratic polynomial. So it's going to get a whole lot more interesting and subtle, but don't worry, we're going to go through it very simply. So you have limit x goes to 5 of x squared minus 2x minus 10. So first step is what the limit should be. What should it be before we prove that it is that? So if we plug in x equals 5, again, it's a continuous function. So you have 25 minus 2 times 5, which is 10. So 25 minus 10, which is just 5. So that's going to be our limit. And now we just need to prove that that is correct. So again, we want to make the absolute value. So I'm going to write this out. We want to make the absolute value of x squared minus 2x minus 10 minus 5. We want to make this small given that the absolute value of x minus 5 is small. Okay, so I'm phrasing this in a number of ways to just intuitively connect it to the Epsilon-Delta proof. So in other words, we play a game. If I want this to be less than epsilon, okay, if I want this distance to be small, in other words, this x squared minus 2x minus 10 to approach 5, you're going to tell me a delta so that as long as the absolute value of x minus 5 is less than delta, I can guarantee that my x squared minus 2x minus 10 will be that close to 5. Okay, so how do I find that delta in terms of epsilon? Or how do you find that delta in terms of epsilon? What you need to do is you need to write this expression somehow in terms of x minus 5. So this is the preliminary steps, okay? It's not the actual proof that will come later on that side of the board. The preliminary steps, I'm not saying that right. The preliminary steps is we need to write this in terms of x minus 5. So this is going to make sense, okay? This is just going to come to factoring our quadratic. So you're going to have the absolute value of x squared minus 2x minus 15, okay? So that's going to be our quantity. And of course, we know this has a 0. By definition, by sort of the way the intuition is going, when x is 5, this is 0, right? Because we want to show when x approaches 5, this approaches 0, but we know when x is exactly 5, this is 0. So this is going to factor, okay? So we can factor a quadratic, using the middle term or the quadratic formula. It's x squared minus 5x plus 3x minus 15, and then you can do the factoring. I'm just going to do it in one step. It's going to be x minus 5 times x plus 3. Okay, and one quick check is just to plug in x equals 5 and x equals negative 3 and check that. You get 0 for this, okay? So x equals negative 3, you get 9 plus 6 minus 15, so it's 0. So you've got that. We want this to be less than epsilon. Now, this is a little trickier because it's not a constant now that we're multiplying the absolute value of x minus 5 by, right? So we're multiplying it by x plus 3, and that's a function of x. So how are we going to handle this? So before I get into the proof, I'm just going to tell you the intuition first of all. And the intuition is pretty nice. It's pretty cool. Basically, we have the absolute value of x minus 5 times the absolute value of x plus 3, okay? And that we want that to be less than epsilon. So what should we take delta to be? Now here's a fallacy, okay? I'm going to tell this to you as a fallacy. We cannot take delta to equal to epsilon divided by the absolute value of x plus 3. Okay, this is actually wrong. Why can't we take delta to be that? Well, delta should be dependent only on epsilon. Okay, so it cannot be dependent on x. Okay, there are a lot of different quantifiers in this. There is the x, there is the epsilon, there is the delta. We have to make sure our delta is only dependent on epsilon. Once I've specified how close we want this expression to be to 5, which is by our epsilon, you need to tell me a delta that is independent or dependent only on epsilon but independent of x. So as long as the absolute value of x minus 5 is less than delta, we have this expression. So how are we going to find our delta? Well, basically, we're going to have to be a bit clever here, okay? And this is the trick we're going to use. When x is exactly 5, our x plus 3 is going to be 8, okay? So our first guess is to take delta equals to epsilon over 8. The problem with this is that it doesn't universally work, because remember, when x is close to 5, x can be either to the right of 5 or to the left of 5 on the number line. So if we imagine a range, I'm just going to be very specific here. Imagine a range from 4 to 6. Then our x plus 3, when x is equal to 6, our x plus 3 is going to be 9. So as our x approaches 6, our delta should be epsilon over 9 to ensure that if the absolute value of x minus 5 is less than delta, but also x is close to 6. Okay, let's say we don't know anything about delta. Delta could be large. But when x is close to 6, then our x plus 3 is going to be close to 9. So our delta should be epsilon over 9 there, but as our x gets close to 4, our x plus 3 is going to get close to 7, so our delta will be epsilon over 7 here. Okay, so we need our delta to be small enough. That's our luxury, that we can ensure our delta is as small as we like. We can pick a delta, it can be as small as necessary as long as we ensure that this quantity is less than epsilon. And so what we're going to do is we're going to pick the smallest of the two values. Okay, if delta is epsilon over 9, that's going to take care of any x in this range from 4 to 6, right? So if x is within 4 to 6, which you can ensure because we can make delta as small as possible. So first step, I'm going to say, or you're going to tell me, the delta is going to be less than 1. Okay, we're going to make delta less than 1 by default. Doesn't matter what epsilon is. Epsilon could be 100. Make delta less than 1, fine. And then on top of that, you want to make delta less than epsilon over 9. Okay, so that takes care of, as epsilon gets really, really small, then delta should be less than epsilon over 9 because you're going to wiggle to the left or to the right of 5. So I hope that makes sense, but I'm actually going to write the proof now. Okay, so you're going to see it in action, which hopefully will clarify things. We're not going to take epsilon over 8, we're going to take delta equals to epsilon over 9, and you're going to see this work in action, okay, when you write out the epsilon delta proof. So let me erase this and write out the epsilon delta proof right now. All right, so let's write it out. So our proof is, let epsilon greater than 0 be arbitrary, okay? Let epsilon greater than 0 be arbitrary, and we want to ensure, so our choice, you know, when I said 4 to 6, that was not special. I could have gone 3 to 7 as well, okay? And then I would have said delta should be less than 2, okay, because within 2 of 5, and delta should be then less than epsilon over 10. Okay, that's what I would have done. But let me write the proof out, okay? So let epsilon greater than 0 be arbitrary. Let delta equal to, and here's going to be the way we'll express this, the minimum of 1 and epsilon over 9. Okay, so it is going to be the smallest number among 1 and epsilon over 9, whatever that is. So by definition, it's going to be less than 1, or less than or equal to 1, and it's going to be less than or equal to epsilon over 9. Okay, so it's definitely less than or equal to 1. Okay, so we're going to be in this range of 4 to 6, which we're allowed to do. We can choose any delta as long as it serves our purpose. Okay, now we have that if the absolute value of x minus 5 is less than delta, then we know for a fact that the absolute value of x squared minus 2x minus 10 minus 5, and I'm writing this slightly differently from last time. We want to make this quantity small. Okay, so I'm going to now simplify it to something in terms of absolute value x minus 5. You can do it either way, or you could just write out in the other direction. So I'll explain that. You can write out x minus 5 times x plus 3 is going to be less than this, and then backtrack to this quantity. We can do it either way. But we're going to do it this way. Then this quantity is going to be the absolute value of x minus 5 times x plus 3, which we know, right? We know that because we've just factored the quadratic like we did. Okay, this is now our proof. So we factored the quadratic, and we know that because the absolute value of x minus 5 is less than delta, okay, so we know that delta is the minimum of 1 and epsilon over 9. We know for a start that the absolute value of x minus 5 is less than epsilon over 9, right? Because delta is the smaller out of 1 and epsilon over 9. So it's going to be less than epsilon over 9 times the absolute value of x plus 3. But now here's the deal. X plus 3, right? Because delta is the minimum of 1 and epsilon over 9, so we have the 1 as well. We know that x is between 4 and 6. So the maximum value of x plus 3 is going to be 9, right? Because x is between 4 and 6. It's not going to quite hit 9, okay? But because x is, absolute value x minus 5 is less than delta. But therefore, we know the absolute value of x plus 9 is going to be less than 9 because x is less than 6. And so that means that this is going to be equal to epsilon. Okay, so we've got a strict inequality here. So we've ensured that, you know, whatever epsilon I've chosen, you found a delta, which is the minimum of 1 and epsilon over 9, to ensure that if the absolute value of x minus 5 is less than delta, then the absolute value of this expression x squared minus 2x minus 10 minus 5 is less than epsilon. So we've ensured that no matter how close I want x squared minus 2x minus 10 to be to 5, you can find a certain degree of closeness of x to 5, because we have the limit as x goes to 5. You can find a delta, playing a game, so that if absolute value x minus 5 less than delta, then absolute value x squared minus 2x minus 10 minus 5 is less than epsilon. Okay, and I hope that makes sense. And I want to make one point is we could have, our 1 was arbitrary. Okay, so this helps sometimes. If you're studying this, you may wonder, why did I pick 1? Well, if I picked 2, that would have also been fine. But if I picked 2, I would have had to make this epsilon over 10. Because then if I picked 2, all we knew is that x would have been between 3 and 7. And then when x is 7, we know that our x plus 3 is going to be 10. So we need our x minus 5 to be less than epsilon over 10 here. Here we'd only need it to be less than epsilon over 6, but our worst case scenario is to absolutely ensure, in this case we need it to be much smaller. So we just pick epsilon over 10 as delta, and then we would say min 2 comma epsilon over 10. Okay, and I want you to drop a comment down below. Okay, just as a practice, what if I said min 0.5? What if instead of 1 I said 0.5? What could I choose this epsilon over 9 to be? Okay, what are some options I could choose so that it would ensure that if the absolute value of x minus 5 is less than delta, then the absolute value of x squared minus 2x minus 10 minus 5 is less than epsilon. Okay, so that's an exercise to you. Now we're going to get to the next one. So I've got 3 more, and I hope you're loving this video. Please don't forget to leave a like and subscribe if you're enjoying my content. It makes a huge difference to my channel. And if you're really enjoying my content, please consider subscribing on Patreon. Okay, it makes a huge difference. I do everything on my own, and I'm trying to build this channel to create elite, infinite, free, accessible math education at all levels for everyone. And I'm deeply grateful to everyone who supported on Patreon, Alex and Nathan, for their ongoing support. Thank you so much. I hope you're watching this video, and if you're considering supporting, just check out my page. It makes a big difference for me, and I'm super grateful. I deeply value everyone who subscribes and everyone in general. Okay, it doesn't matter, even if you choose not to subscribe, deeply value the fact that you're watching, and I hope I'm delivering a lot of value of content to you. It's all free content, and I'm so happy I'm able to do it to help as many people as possible. That's my ultimate goal, to change lives through math education and create a repository of advanced math across everything that currently doesn't really exist. There's basic math, there's some advanced math, but nothing with everything, and that's what I'm trying to do with this channel. So let's get into the next one now, which is going to be another fun epsilon delta argument.